inviting me here. My name is Uri, and I work at the Negev campus of the Ben-Gurion University, which is located a 45-minute drive in a small, beautiful village just by the cliff of the Negev Highlands. And in our group, we do a lot of things related to biodiversity. A lot of it is large scale and conservation biology and their links. And in many of our projects, we actually use on a daily basis either AI tools or big data or both. What I'm thinking of doing here in the next few minutes that I have is just give a very, very brief overview of some of the projects undertaken in my lab. And of course, as any of you that have students know, we don't know anything. It's all the students' works. We're just taking credit for everyone, which is what I'm doing here. And so sorry for this to begin with. So just so we are on the same page, is that what works? Yes, so it's something very, very different from what they had until now. Very, very large scale. A lot of the things I will talk about happen way, way beyond even the organism. I hope you'll bear with me. And a lot of the driving force behind a lot of what we do in the lab has to do with this age that we live in of biodiversity and climate crisis. And that gives us several very, very big challenges that at least we tried in some of our work to tackle. This have to do with, obviously, how do we turn the tide on these destructive processes? How do we make sure that the limited funds that we have for conservation actually make a difference? So how do we prioritize them, be it for particular places or species and so forth? How do we make sure that when we want to do conservation, it's not just, I've done something and then after a couple of days it's gone or a couple of years it's gone, by engaging the public, a lot of the time indifferent, a lot of the time preoccupied with other things, into the things that we do. And we think that, at least to a degree, big data and AI tools can help, and I agree completely with what you said. Also, it's not the end of the line, but it can definitely open up some interesting new avenues. And in our work, a lot of what we do is, by definition, applied. We try to work, we've been working with these global organizations for conservation in the past few years to try to make sure that the knowledge, the data, and the insights that we have actually make a difference for the betterment of our planet. So how can big data help in this sphere of biodiversity or big data for biodiversity? So we nowadays have smaller and smaller tracking devices that we can put predominantly on animals, but not just, and follow them in a very high spatial temporal resolution and try to understand much better what it is they actually do, where they go, and so forth and so on. There's a lot of remotely sensed data that's becoming, again, higher resolution in space and in time with hyperspectral data that can give us a lot of insights on planetary things, even at a fairly small scale. The classical sources of information, of location information, behavior information, and so forth, are being digitized. It can also help us. And then the more novel approaches had to do with citizen science, so engaging public specifically in targeted endeavors that can help us gain more information, and in doing so also engage them in the things that we do, and also using the wealth of information that's found online, not deliberately, but inconsequentially by just our engagement with the planet via these things almost constantly. And this is culturomics that Ofer just mentioned, and macroecology. And if you've never heard these terms before, it's okay. I'll try to explain them in a bit. So I'll just jump into a few examples. And this is a project done by Krista, tagging this bird that you see here, which is called the Arabian Owl, which is the only species of bird in Israel that has a social life, so a group lives together. And what we have is around where we live here, this is called the Tzin Plateau, in and around the village of Sde-Boker. I live here. We set up a whole bunch of antennas, and then when we catch the birds, we can put a tag on them that weighs as little as 1 gram, and we can track them for months at 8-second intervals at up to 10 to 15 meter spatial resolution. And this is just an example that she's found in each one of these groups, named kibbutz, so forth, how they interact differently in different seasons. So it's the same groups in the same area, and as the area becomes a bit greener in the winter, she can see that there's so much more interactions between the groups. Data that would have been very, very hard, if not impossible, to gain by other means, because then you have a set of people with binoculars making sure that they track each bird, and of course you can't identify something that looks like this very easily, and now we tag them and we can gain this information about them, and we can see the effects, for example, on human-modified habitats on these birds, and other interesting questions. Reut Vardi, currently at Oxford, one of her projects was really interesting to see if indeed during the COVID period, this notion that we had that animals were overtaking our cities was indeed correct. And rather than, again, going outside and trying to catch many, many species, which obviously you can do, if you try to take a more, again, broad big data approach. She took a lot of observations from iNaturalist, which is a citizen science platform that where people record presence and observations of animals, for a few species of large mammals in North America that are very, very, it's obvious that people see them. So that was the location information, so she did it both before COVID and during COVID. And then she took remotely sensed data about night light, which is sort of a proxy of urbanization. And she tried to compare whether places before COVID and during COVID had more urban observations using another machine learning method, and she found this is true, so on the face of it, yes, during COVID, the big wildlife was overtaking the city, but the second thing she did, which was interesting, was seeing in the new places that people see them during 2020, during COVID periods, are they more or less urbanized? And what she found is that actually for most species, they were less urbanized, apart from the puma here. Which means that, yes, we saw this phenomenon of animals overtaking city, but it was probably much more changes in human behavior. We stayed at home, we became bored, we started recalling species more and more in the cities, but actually most of the animals have already been in the cities, we were just oblivious to them. In this project, Enav has been collecting millions of location data for Israeli animals and plants from a whole variety of sources, both citizen science and the more classical sources that have been, that as I said, are being digitized, together with a very complex optimization algorithm to try to think where should we extend Israel's nature reserves to optimize not just species richness, which is the classical one, but the actual composition. And once you think about it, this all of a sudden becomes a very complicated optimization problem, because if we divide Israel, let's say, to 1 by 1 square kilometer cells, let's say we have 28,000 such cells, each one has a presence matrix of between 0 and thousands of species in it. How do I make sure that within a confined space, in this case, we're taking 30% of Israel, do I get the best sort of value for the buck? And then I can add to it also a cost layer, which means that not all areas that I can choose are equal, so I can choose areas that are more likely to become a reserve and so forth. And the areas here in purple are but one such example of where we can extend current nature reserves in green to make sort of the best the best conservation for the buck. In this work, again, another former postdoc in my group tried to see the effects of climate change on global biodiversity, and in this case he was specifically interested in extreme heat events. And what he did was he looked in the past, between 1950 to 2005, the distributions of all global what's called land vertebrates, over 30,000 species. What were the most extreme heat events that they experienced in the past? Sort of like the 1% crazy day where they had, it's not a day, it's usually a span of at least 3 to 5 days that they had in the past. And then he took these values per species and they saw how likely they are to experience them at the end of the 21st century. Underneath this, in this case we just showed 2, but he did it for several, what's called emission scenarios, i.e. how we continue to burn carbon fuels or we stop doing it. And what he's seen that for, if we continue with burning it, it's what's called business as usual, the rate we're doing today, then thousands and thousands of species will experience extreme heat events that they experienced maybe once in a year before, throughout at least half of the year or throughout half of the range. So this is going to be very, very dramatic. We didn't include people here because I think it would have been too shocking for us even to think about that. Here, again, another former postdoc used threat status data for 7,000 species with something of thousands of different features with an XGBoost algorithm to try to predict the threat status for thousands other species that have yet to be assessed. I'm running through it, I'm sorry, but I'm trying to show you some examples. I'll be happy to answer questions later about this. But as I said before, we can also harness this wealth of information that we have here at our fingertips via these fields called culturomics or ecology to try and better understand both human-nature relationships and basic ecological and evolutionary data. So culturomics in itself is the study of human cultures, as these are manifested in the ever-expanding online web. Conservation culturomics specifically is interested in human-nature relationships. What are we interested in? What can be like the target species that we should protect, which are falling by the wayside, and we may lose them because of popularity. If we've done some conservation campaign, has it been actually successful? Have people actually followed it and commented on it? Do they like a particular initiative that we did, or do they don't like it? All of these things we can understand, again, by automatically harnessing some of these patterns. Ecology uses the same exact data, but to look at basic ecological or evolutionary patterns. So if I take a picture, or I take a selfie, which obviously I never do, but take a selfie of me next to a tree, and I geotag it, and I have the data on it, someone can look at the back at the tree and see if it's leafing, is it flowering, is it now in fall, just as an example, okay? So a lot of these data can later be accessed, and I'll show you a couple of examples for that. So here, during 2010, there was a convention for biological diversity in the prefecture of Aichi in Japan. And together, all of the countries that are signatories on the CBD, which is almost all countries globally, decided on 20 targets to be achieved by 2020. These targets here, marked by different icons, had a lot to do with protecting biodiversity. And the first one was, by 2020, there's been an increase in people aware of biodiversity and how to best protect it. Okay, so they set up this target, and then 2010 came and flew by. There were other things on our mind, we're going to see them in a second. But how do we actually check if this works? So in this case, Gabriel again went to Google Trends and he collected hundreds of different terms from reputable sources having to do with biodiversity. And he looked at trends in the time series of interest in these things, as these are manifested in Google searches across all countries globally. So we're talking about 250 countries, daily time series of hundreds of terms. Very easy to see how it becomes very big data. And what he saw is, at least for things that having to do with biodiversity, we do see an increase throughout most of this decade. Terms that have to do with the protection of biodiversity, we see a very sharp decline over 2020. Again, we think this has to do with the fact that once our focus was shifted towards COVID, the space in our mind for interest in protecting biodiversity sort of declined. And again, we have other sources of support for this notion. He can map this, he can map on the world. Where are the places that have more or less interest? Where are the places that improved the best or did not? Both for biodiversity and for countries. And then he also modeled what are the potential socio-economic drivers that can produce these patterns in a semi-mechanistic way. Another really cool example that I like to give is this of monitoring migration of birds. So this is a barn swallow, a bird that you can see even here on campus if you go outside. In Israel, they also migrate through Israel in large numbers, and this is also true in Europe. And what you see here in Europe, and this is, there's an arrow here, this should be Catalonia, and this is Italy, Germany, Austria, Sweden, and Norway. And when you look below at observations, that this is also true for animals that were actually caught in the hand, you see the migration wave in the spring from Southern Europe to Northern Europe, which makes sense. So first you see them in the southern countries, then you see in Central Europe, then you see them in Northern Europe. So this is a pattern that's been known through the ages. The interesting thing is you can study this migration without seeing a single bird, just by looking at trends in Wikipedia page views. And this is what you see here. So these are smoothed lines of the number of page views in Catalan, Italian, German, Swedish, and Norwegian. And you see that they follow the same trend. People's interest in these birds follow the same migration pattern that the birds themselves do. Another project that now we're working on in the lab has to do with trying to monitor the status of some of the most charismatic fishes in the Red Sea. So these are parrotfish and groupers, which are both beautiful, charismatic, and unfortunately to them also tasty. And we know that across the Red Sea there's a lot of fishing, a lot of illegal fishing. There's some protected areas, but there are also places with pollution. And even though Leila would have loved for me to send her all across the Red Sea to sample these things, it's very difficult, and in some places, like I probably would not send her here to the coast of Yemen to sample fishes nowadays. So what we decided to do is actually look at videos on YouTube that people have uploaded because they went diving and they like it and they want to share with their friends. And from these videos extracted images of fishes automatically, and from these identified automatically those images that belong to one of our two target groups, and now correlate them with various aspects of conservation aspects related to the Red Sea, where they were taken, so forth and so on. And one of the things that we found that there's definitely still a way to go in this process, because, for example, when we correlated it to actual structured survey data of experts of fish abundance and presence around Eilat, we found that there wasn't an amazing match at least across some aspects, but across others, maybe there's the potential to see some trends. This is, by the way, how the first fish classification happens. You see, so a lot of the time it says it's a fish, but sometimes it says it's a penguin, and then other fish arrive, and then the idea is we cut these frames, identify this fish, and then we run them through the second phase of the model that identifies it to which group of fish it belongs. Yeah, so I think this is more or less my time, and I would like to be very grateful to all of the collaborators and students and funding sources, and if there are questions, I'll be happy to take them.
Questions, please.
So how do you identify location based on the video?
Yeah, so this is a good question. It's hard. So sometimes people actually tag videos in YouTube. Sometimes you can identify in the video very pronounced elements in it if you go through it. But this is definitely today still a semi-automatic and not a fully automatic mechanism, at least using YouTube videos. There are some sources, for example, Instagram, where the geotag is embedded in the system every time you load the picture, unless you opted out, which will also be geotagged. However, Instagram, you cannot access their data automatically via what's called an open API. It's a proprietary data, and they don't share it with the world as opposed to YouTube. Okay, so this is a good question. Leila had to work quite a lot to actually obtain location information, at least for some of these things.
No more questions?
Sure. Thank you very much.
Thank you.